Alright, so another little example here involving an integration of a series. So here f of x is going to equal the series from n equals 0 to infinity, x to the n over n factorial. H of x is going to be x to the third times the integral from 0 to x of our function, f of t dt. And we want to find a series representation for our function h of x. Alright, so the first thing I'm going to compute is the integral from 0 to x of f of t dt. Well, if we replace the x's with t's, we'll have the series from n equals 0 to infinity. Well, t to the n over n factorial. And again, we're just integrating with respect to t. Well, again, we can do the same thing as before. We can pull our summation out front. N equals 0 to infinity. The integral from 0 to x of t to the n over n factorial dt. So we'll have the series from n equals 0 to infinity. When we integrate this, you can think about the 1 over n factorial as just being a constant. Again, we're integrating with respect to t. So if we integrate, t to a power, well, we add 1 to the power, divide by that new power. Again, this is a definite integral, so we can just plug in our limits of integration, 0 to x. And well, if we plug that in, notice we'll be left with, we're again replacing the t. We'll have x raised to the n plus 1 power over n factorial times n plus 1. When we subtract away the lower limit of integration, we're plugging in 0 for t, so we would just be left with 0. So hey, it says all we're going to be left with is the series from n equals 0 to infinity. We've got x to the n plus 1 over n factorial times n plus 1. And now all we have to do, again, because I the only thing I computed there was the value of the integral. Well, we still have to multiply that now by our x cubed, so let's not forget about that. So it says h of x is going to equal x cubed times the integral, which we've calculated here to be the summation from n equals 0 to infinity, x to the n plus 1 over n factorial times n plus 1. Well, again, we've seen when you multiply, you can just run the x inside. So really, we could think about this x to the third as being inside the series. But, you could think about that as being over 1. So what we'll be left with is the series from 0 to infinity. We can add exponents. N plus 1 plus 3 is going to give us to the n plus 4th power over n factorial, n plus 1. And now we have our solution.